Can those online, can you hear me okay? You could do raise a hand. Okay, great. Just because they just fixed the microphone, so we should be good to go. Awesome. All right, so my goal today is to finish 2.1. We're gonna have some downtime today, so I'm gonna do some practice with y'all. I brought my textbook so we can do some extra problems. I just don't want to waste the precious time we have in lecture when there's a lot we can work on once we know these, certain skills. I did add some more homeworks, so take a look. I've added them in. They had the same deadline as before. I'm working on quiz 3. Quiz 3 will open on Friday once I've figured out what we did this week, but quiz 3 will cover what we did this week, and then you'll have the same deadline as before. So just stay on top of everything. The more you do this week, the less you have to panic and do the week of the exam, and you can have more time to study actual exam questions. So do more now. All right. Any questions before we get started? Okay. So we're going to finish naming. We've done alkanes, we've done binary covalent molecules, and we started working on ionic nomenclature. So we haven't finished it. We're going to finish it today. But just note you will be expected to answer everything. And so I'm going to continue adding alkanes and binary covalent molecules. So you've got to kind of build off of what you've already learned, and then we will continue to keep adding and adding. So today we're going to finish up naming with polyatomic ions. So it's the same goal as parts 1 and parts 2, to write names and formulas for ionic compounds composed of a metal and a nonmetal, or a polyatomic ion. I will warn you, polyatomic ions will always be nonmetals. So they're going to be a metal plus a variety of different nonmetals that create one giant unit, or it'll be individual ions. Before we get started, I want to brainstorm if y'all know of any polyatomic ions. No worries if you don't. This example here, this is ammonia. So if it was just NH3, it would be ammonia, and it's not an ion because it doesn't have that charge. This has a positive +1 charge. So this is an ammonium ion. Okay. Do y'all know of any other ions on top of your head, polyatomic? So if I was to say nitrate, have y'all heard of nitrate? So nitrate is NO3 minus. So if you like to garden or if you're into agriculture, nitrates are very important for plant health and fertilizers. So when you think nitrate, I want you to start getting more comfortable recognizing nitrate is NO3. And then the charge of that ion is a -1. Any other? Does anyone have any other ones they can think of? Okay. There are so many. No worries if you can't think on top of your head, but there are so many polyatomic ions out there, and our goal is to eventually memorize. But my biggest piece of advice is the more we practice, the more easy they will come to us. So you can't just have a piece of paper in front of you and expect you to memorize, but as you do the homeworks, as you work in class, it'll come more naturally. So really work on trying to remember them instead of just potentially, like if you're doing your homework, looking it up. Our goal is to try to get them in our heads. So we built on this. For part 1 of this series, we did fixed charge metals. So remember that fixed charge metals are the metals that have, for cations, positively charged. Fixed charge always will have the same charge no matter what. So that's column 1, which has a charge of what? Positive 1, column 2. What about silver? What about zinc and cadmium? Okay. And then if it's an anion on the other side, the nonmetal, what about the second to last column? So the fluorines all the way to the iodine. -1. Oxygen to oxygen down. Okay. Nitrogen down. Carbon. That one's the one I kind of got tricked on. -4. Okay. And that's going to be our fixed ones. They will always have the same charge no matter what, with the exception of if it's a polyatomic, which those will also have fixed, but I'll show you the examples of that. Part 2, we introduced the second one, variable charge metals. So some metals can have various charges, and the way that we can determine what charge that is, if they were to write out the name, is the Roman numeral tells you the charge. Sometimes you're not as lucky, because what if I was to give you like Al3? Oh, aluminum is also, no, it's not. Yes, I think aluminum is also one of those fixed one that's always 3+. But if it was Al3 and then Al2O3, you can always determine what the charge is by using the crisscross method, which I will show you again. So if I give you something else that was a 3+, let's say chromium 3+, so Cr2O3, how do I know what the charge of chromium is? So we'll practice that crisscross method, but we went over that in part 2. In part 3, that's what we're doing today, is now we're going to keep and add on the polyatomic ion. The good news here is we're not playing around with prefixes anymore. We're not playing around with any of that. If I throw in a polyatomic cation or anion, it's just the name. And I'm going to tell you now, there's only one polyatomic cation, and that's ammonia. There's only one positively charged. Everything else would be a negative charge. And I like that, because I don't have to think about, okay, if I have 2 ammoniums, is it diammonia? No, it's just going to be just the polyatomic name and then whatever else. Part one, part 2, and part 3. Let's write out these names. So first, I do want to pass this out. I wanted to test y'all before y'all had a sheet in front of you that had the polyatomic. On the back side, this is what I think is better option for my name. If you are online, go to the resources tab under our modules. I added a new resource. It's with polyatomic. It says polyatomic ions to memorize this week. And I have a list of polyatomic, but even better, on the back side helps you how to name them. So I would definitely have that printed out with you while you're practicing names. So remember, when it comes to polyatomic, the second you identify what polyatomic ion it is, you're not playing around with the name. You're leaving it as is. I also note, like previously we worked on binary covalent when it was only 2 elements. Now that we have more than 2 elements, I have to recognize which one is the polyatomic ion. You're not going to mix metal and non-metals in polyatomic. It's just going to be non-metals. So I need to be able to look at it and say, this is the polyatomic ion. And then I had on the previous slide, what is that polyatomic ion? Nitrate. Okay. What's this element? Sodium. Remember that with metals, because sodium is a metal, we're not playing around with the name. Whatever that metal is, I put it up there. Do I need to put a Roman numeral after sodium? No. Why? It's fixed. So it's redundant if I was to add it. So it would be incorrect. Sodium does have a +1 charge always. And so because I always know it's a +1 charge, I just leave it as sodium and then nitrate. Nitrate will always have a -1 charge. That's the whole thing will have a -1 charge. So that's why there is no like double or numbers in there. What metal is this? What is the charge of calcium? If you do not have this memorized, and this is honestly how I do it to this day, because sometimes I struggle memorizing my polyatomic ions. This is a polyatomic ion. If you don't have the sheet in front of you, you can still kind of use deduction reasoning to figure out what the charge is. So if calcium has a 2+ charge and this overall compound has a neutral charge, what does this compound have to have a charge of? 2-. So that's going to be very helpful if you have a fixed metal to figure out what the charge of the other thing is. Now, does anyone know what the name of this polyatomic ion is. So it's on this back sheet. Let me find it. It's at the bottom of the orange. Yes, this is sulfate. And sulfate always has a -2 charge. This one, next one has 2 polyatomic ions, which kind of makes it a little bit more confusing, but we don't play around with prefixes. We just, all we have to do is identify what polyatomic ion it is and then write it out. So NH4, I've already shown you, but does anyone remember what it is? Ammonium. And ammonium will always have a +1 charge. Whatever this other element is, can you tell me what charge it has to be? Yes, and even if I don't have that memorized, I can deduce that that has to be it because there's only one of it and it has to have a minus charge to make it up to be a neutral compound. But if I look at this sheet, this is when you want to look at the first blue box, I guess, under patterns to extend. It's ClO3. So if you look under, it says up top, you find the Cl and it has chloro on top. And then it has down here, you find the ClO3 and that's the space. So it says space 8. So it would be chlor8. Yeah, we're all able to like make the deduction. And this will be very helpful even for myself because there are certain ones that I don't quite have memorized yet. And so I'll have this sheet in front of me and say, okay, where does it go? So ammonium chlorate. All right, and this next one, I want to remind you, even if I have multiple of these ions, it doesn't change the name. This will not be a di in front because whatever the name of it, polyatomic ion it is, you keep the name as is. Okay, so we've already know that this is calcium. And then what is this polyatomic ion? This is hydroxide. So calcium has a 2+ charge. What is going to be the charge of each hydroxide? -1. Since there's 2 of them, that's why it is now an overall neutral charge. But like I said, just because there's 2 of them, we put polyatomic ions in parentheses and the number behind you tells you how many. So if, let's say this is calcium fluoride. This is pretty much the same thing. There's 2 of the anion. They have the same charge on them, but I don't need to put parentheses around chloride because it's an individual element and it's not necessary. But since I have 2 elements combined, I have to put a parentheses around it because if I didn't, this would be a completely different compound. So if I start having more than 1, you'll see the parentheses and then the number behind it tells you how many of them. These are great practice. I have a lot more. Right. Let's just review the crisscross method. If it's something like sodium and hydroxide, sodium has a +1 charge always. Hydroxide has a -1 charge always. Since I have a +1 and a -1, I put it together and it's 0, it will always be NaOH, always. But what happens if I have different charges that don't add up to be neutral? A good example of this would be like, let's say I have chromium. What do I do? What do I do? Wrong number, sorry. I want to do a 3 right here and I want to do a 2 right here. This is the same thing as if I did chromium. It's the same thing. It's the same units. You just have to remember that polyatomic ions are kind of treated inside the parentheses. So the crisscross method is if I know chromium, skip the method. is a 3 plus and oxygen is always a 2 minus. So chromium can vary, but I know that oxygen is 2 minus. You put the crisscross method, and that's why it's Cr2O3. Same thing here. I just have to keep it in parentheses. So crisscross method. So you've probably gotten very comfortable using the binary with the two different elements, but it's very, very similar for once we introduce the polyatomics. Let's keep practicing. This is what I showed on the previous slide. So when we crisscross, if you need to write a subscript on a polyatomic ion, add parentheses around the formula of the ion, because if you don't, you'll have a very different compound that is going to be very confusing. So if I was to have NO3 and there's two of them, I don't just add the two to the end, because CaN 32 oxygens just does not exist. So the way that you do it is in parentheses, you put the polyatomic ion and then you put the subscript after it. That's why you want to make sure you're doing parentheses if there's more than one. And this just takes a little bit of practice. Oh, I have a question. Let's do a little practice here. Before, when we were doing equivalence and dimensional analysis, I had given y'all a compound like this. And I'd ask you, okay, so if I have one molecule of CaNO3, 2, how many calcium atoms do I have? One atom of calcium. How many atoms of nitrogen? So this 2 will go into both of these. Okay, so I will have 2 nitrogens. And then how many oxygens? 6. So that's why it's also important to keep that, because if you have 2 nitrates, you have to have 2 nitrogens. If you have 2 nitrates, there's 3 on each, 6 oxygens. So we can still do dimensional analysis with these types of compounds. Just make sure that if you have it in parentheses, using that math function, it has to be done to both of them. Let's practice writing the formulas. Reminder, if it's a fixed metal, we don't need to include the parentheses or the Roman numerals, but the Roman numerals tell you what the charge is. So let's do number 1 together, and then I'll let you do the rest. So chloride, that is not a polyatomic ion. So previously we discussed that if it's just the element by itself, you take out the last 3 letters and replace it with ide. So chloride is just going to be Cl. So copper, what's the charge of copper here? How do I know that? Yeah, because of Roman numerals. So Cu2 plus, and then chloride, what is the charge of chloride always? I can't leave this as is because they don't add up to be 0. So I'm going to use the crisscross method. And now I have CuCl2, and that is the correct formula. So 2 plus, and then -1 and -1 add up to be 0. So that is the correct compound. I'll let you practice the other ones. Use the back side of the resource I just showed you, because that's going to be how you figure out what are the other ones. So I'll give you a few minutes. One more minute. Or, sorry, one more second. All right. So the next one, we have copper with a +1 charge. What is chlorate? What is the formula for chlorate? -1? Do I need to have subscripts here or do any crisscross? No, because if you add them up, it equals 0. So the overall compound would be CuClO. Chromium, and that's 6. I initially said that was a 4. That's not a 4. So that's chromium 6 plus and chlorite. What is chlorite? All right. So in this case, I have to do the crisscross because they don't add up to be 0. So I would have 1 chromium attached to ClO2 in parentheses, and then there's a 6 at the end. I can't just do O2, then a 6, it just wouldn't work out. So you need to make sure that the entire polyatomic ion is in parentheses. Lead, we have Pb4 plus, and then nitrate, NO3 minus. Once again, we need the crisscross. Did y'all get that? All right, barium. This is a fixed metal, so it will always have a 2+ charge. Let me double check. All right, I am right. So Ba2+, and what is carbonate? So this one does not need the crisscross because if you add them up, it's neutral. So BaCO3. Did you get these answers?
Where do we find chloride?
Chloride. So that one is in the second one, third one down. So you see chloro, and then there's a blank ite. So yeah, that'll be ClO2. You see how like, it's hard to have these memorized when they're so close to each other.
Yeah, I wrote it or chlorate, so I was looking up at the screen.
Yeah, this is going to be a learning for all of us. Just lots and lots of practice gets these stuck in our heads, I promise. Let's continue practicing. I'll do the first one with you, and then y'all do the second too. So tungsten, that one's going to be a W. This is a 6, so W6 plus, and then it says hydroxide. Hydroxide is OH minus. Okay, I will need, because it's asking for the name and the formula, so I'll do the formula on top. We have to crisscross. And when I do that, I get tungsten hydroxide with 6. Tungsten is not a fixed metal, and so I have to have in the name the Roman numerals for the charge. But even if I have 6 hydroxides, I don't have to worry about prefixes. I'm just going to leave it in as hydroxide because I can always figure out how many of them are based on the charge of the tungsten. But this would be the correct name, tungsten 6 hydroxide.
So they say every time you see a Roman, the following, I guess, polyatomic ion and element in the B.
I can't say it's safe because what happens if you have like a 3 and a 2? So far, all of the polyatomics have been a -1 charge, except for like this one. If it's a -1 charge, then yes, you can make that assumption. But right now, I'd rather us not, because if I start introducing you -2 charges, -3 charges, it's not going to always equate to being that.
Okay.
Go ahead, let's do tungsten with a 4. Y'all do that one. Don't forget, it wants formula and name. All right, number 2, we have tungsten with a 4+ charge and sulfate. What is sulfate? So sulfate, I think it's SO4. Let me double check.
Yep, that's a four.
Okay. So it'll be SO4 2-. Make sure you have the correct charge here. This one also will need a crisscross, but it can be simplified. So you'll crisscross it, but then just know if you can divide them out by 2, you can. So that'll be WSO4 2. Did y'all get that? Okay. So the name, and you still need to have that Roman numeral, but you don't have to play around with the ion. So it's just going to be sulfate. Did you get that? Perfect. All right. Next one, ammonia, NH4+, and then nitrate, NO3-. I don't need to crisscross. So this will just be NH4, NO3. And then remember, polyatomics, leave the names as is. It'll be ammonium nitrate. I like that because I'm not trying to make our lives any harder than it already is. And there you go. So I promise you, the more we do it, the more it'll stick. So I'm going to ask everyone right now to pull up this worksheet. I'll put it up here. If you don't feel like downloading it, I'll have it up for you to look at. But pull up this worksheet. The key is online and available to you, but we'll work on this for 10 minutes and then we'll go over the answers. As you're naming, remember that you still have access to this nomenclature how to name document. If you don't have it, I have copies here, or you can get it online, but this can also help you with naming. So use your resources as you're studying, and then the more you do it, the more it'll stick. But definitely before the exam, practice without your resources. All right, so here's that worksheet. We'll do this for about 10 minutes, and then we'll go over the answers, and then I'll show you some fun practice on Achieve. I'm blinking today, I'm sorry. Okay, let's go over these answers real quick. Just remember, it wants you to put the charges here and then the full name here. And then if they don't give you the formula, we'll write the formula. Copper. This is when we have to kind of use deductive reasoning to figure out these charges. So remember that copper can have a varying different charges. So we can't always assume copper is one charge, but I do know what the charge of nitrate will always be. What is that? I just gave it, sorry. -1. But there's 2 of them. If I have 2 -1 charges, what does the charge of copper have to be? 2. So even if we have a metal that has a bunch of different charges, like chromium can be, you know, +2 to +7, you can use your deductive reasoning with the charge of the other compound to figure out what it is. And then that's why we crisscross and get these compounds. So we'll name this copper, and we have to incorporate the Roman numerals because copper has varying charges, and then nitrate. That's an O3. Au, that's gold. Gold, another one, we don't really know the charge, but we do know the charge of ClO3. What is that? -1? Okay. And there's 3 of them. So what does the charge of gold have to be? So when they add them up, 1 gold, that's a 3+, and then 3, forget the name, this is chlorates. 3 chlorates that are -1 charges, it ends up being neutral. That's going to be gold. And chlorate. All right, so let's remember what we discussed last class. This Pb is lead. Lead can also have different charges, but sulfur will only have 1 charge. What is sulfur going to be? So what does lead have to be? So lead. And then what is the name of the sulfur? Remember, if it's by itself and it's the anion, it has to end in an IDE. Okay. Barium is a fixed element. Well, what is the charge? +2. Nitrogen's also a fixed charge. What is? -3. So barium and then what about the next one? Yep. Remember, we're not using prefixes in ionic compounds. If this was a molecular or covalent compound, then we'd have to start thinking about prefixes, but we don't need prefixes for ionic compounds. Metals plus nonmetals. The next one, Ag, that's silver. Silver is a fixed metal. Remember, fixed metals, I'm not putting the Roman numerals. That's why I left this one out. Silver is also a fixed metal. What is the charge of silver? And sulfur? Okay, so silver sulfide. So once again, fixed metals do not get Roman numerals. If you have a multiple choice exam, I promise you the answer option with Roman numerals will be there to try to trick you. Don't let it trick you. All right, the next ones, flip it around where they give us the name. So here I have chromium, and I know it's a 3+, and it has oxygen, which will have a 2-. So this one will definitely need a crisscross. Crisscross, so I'll have Cr2O3. Did y'all get that? Copper, so the copper is a +1 charge, bromate. Okay, so I'm going to come to my sheet, and I have brome right here, and then 8 here. So it's going to be BrO3-. All right, since it's +1 and -1, I don't have to crisscross. It'll be CuBrO3. And let me know if y'all get a different answer. Okay, next one's aluminum. Aluminum is a fixed metal. Does anyone remember the charge? Yes. And then sulfur is also a fixed one. What is that? -2. This one will require crisscross. Al2S3. Next one, we have chromium, 6+, and then oxygen, 2-. This will also require crisscross, but we can still divide it out by 2. That'll be CrO3. Because if you crisscross it, you get Cr2O6. And with ionic compounds, we simplify it by dividing it out by the highest common numeral, which is 2 here. Next one, ammonium. So ammonium is NH4 plus, and then carbonate. What is carbonate? 2 minus. So this one does need crisscrossing, but I have to put it in parentheses now that it is a polyatomic that has a different number besides 1. The CO3 does not need parentheses. Did y'all get that? Do y'all feel better about that? So we have 4 minutes. I want to show y'all something that I found in Dr. Patterson's last semester stuff. Show y'all real quick. Let me just go. So I added this to our homework module. It is not, there we go. So I added this to your homework module. It is not for a grade, it's just a practice. So there's 2 of them. There is common ions and balancing charges. So this one's great for helping us figure out things like that. So I like the rapid fire of this too. So if I don't have my notes I would do this without my notes in front of me while you're studying, because this one's not for a grade. So our goal is to memorize. So iron, oh yeah, that's iron, not fluorine. So it can't be this one or this one. So it has to be this one. This one, like I'm telling you right now, don't put your notes in front of you. If you make a mistake, it'll tell you and tell you to try again. This one's hypochlorite. And so you just keep doing this. Sodium, it's not this one because sodium is a fixed element. So you just keep doing it. This is iron, iron 3. So this is great, ammonium. So try to do this quickly, and it'll help, get things stuck in your head. Like for this one, bromine is by itself. It's not just bromine because it has a -1 charge, which makes it a bromide. Chromium 3. So yeah, even if you make a mistake, it's okay. I'll say it's carbonate. It's not. Okay, cyanate. It's not. Okay, it's gonna be cyanide. But you want to practice without having your notes in front of you, just until you get more comfortable. And I think this will definitely help you memorize a little better. The second one is about balancing charges. So if you're struggling to figure out the crisscross method, this one is calcium 2 plus and chlorine minus. So I'll move the calcium here, and it says, okay, I have Ca, but I need to add them together, but my total charge is not 0. Our goal is to get the total charge to be 0. And then once it's a 0, you can check your answer, and it'll tell you if you're correct or not. So Na, S2 minus, it's a -1, so I have to have one more positive in there to make it 0. And so just keep doing it. It has so much variety. So calcium 2 plus, I'll do 1 nitrate, but it needs to have 1 more negative charge. Check answer. And there you go. So I think as you're practicing, if you need additional practice, this is awesome. Because I was doing this before coming in to test and see if I've memorized things. And until I'm completely memorized, I'm going to keep, doing this over and over and over. So this is something that you definitely want to do before the exam. Even though it's not a 4 grade, it's going to really help you for that exam. And once again, the way that you find this is you go to modules, go where the homeworks are, and I threw them in there. So they're with the rest of the homeworks. Yeah. Any questions on that? Awesome. So let us take a 5-minute break and come back at 12:55. There we go. Okay. Let us finish up 2.1. We're now going to start mixing everything together and just challenging you to remember everything we've talked about. This is when practice makes perfect, and I have another worksheet to work on. So our goal is to be able to write everything: alkanes, binary covalent compounds, ionic compounds, and know the difference between all of them. This is when it's going to be challenging. If you're rusty or if things just don't make sense now, practice. Because the more you do it, the more it comes to you. And if you don't look at it until right before the exam, you might lose it. And our goal is for you not to lose it, because the exam's going to include everything, even Unit 1 stuff when it comes to the naming. So we're going to keep reminding you to keep going over it. This is that nomenclature naming or naming shirt thing I gave out a long time ago, but I still bring it. So as you're studying, until you got it, use this. But the goal is for you not to use this after a while. You want to take it away. Don't use it as a crutch when you're studying for the exam. Homework and practicing, that's fine. But the goal is for you to be able to name without having it. And that's when you know you are ready for the exam. Because if you have it while you're studying, you're not ready for the exam. And I'm someone who has learned that the hard way. You go into an exam and you don't have your notes. Oh no, I failed. So don't let that happen. We already did this. So pro tip, if you apply the wrong set of rules perfectly, your answer will likely be wrong. So if I was to have, L2. This is an ionic compound. Now we have to start identifying this thing that's a metal. That's a non-metal. So if you were to like put this together and say this is barium dichloride, you would be wrong because you're applying the rules for binary covalent molecules to an ionic compound. It just doesn't work like that. So this would be barium chloride. So I have to use the rules and be able to identify the difference between all of them. This is a great example of a multiple choice question. What is this? This is propane. We're not going to reinvent the wheel. We're not going to have you naming something that we've already discussed how to name in a different way. This is an alkane. So you have to remember that alkanes have those prefixes, and it's an ane, alkane. So propane for the 3. If you were to use the different rules, this would be for the ionic compounds. This would be for the covalent binary. So you can see how using different rules gives you the wrong answer. So we need to be able to identify what is what. So right now, I would like for everyone to get up this worksheet and start working through it. This is a combination of everything. I do want to point out that I have the answers on the back, but some of the answers are a little confusing. It says I, C, or A. Oh, it does. Okay. Over on the back side, the answers are weird. But I is for ionic, C is for covalent, and A is for alkane. So be able to identify what it is and then do your best naming it. And if you want to check your answers, they are on the back. But I did find one mistake. Let's see if you can find that same mistake. If you can find the mistake, it means you know what you're doing. So I'll put it down here so you can see it, but download it. And then we'll go over the answers. Go over a few of these. I'm not going to do the whole list. So, but you know what we could do is I'm going to do this middle one. Let's do this middle one, and then I'll do a few of the top and the bottom. Ionic, covalent, alkane. Covalent, ionic, covalent, alkane. Ionic, NH3. So, yes, you're right. C3H8. Alkane. KNO3. H2S. C4H10. NH4Cl. So here is the trick. Are there any metals in that? This is a covalent compound. Wait. This is an ionic compound. You're right about that. But that's tricky, right? Because it's all non-metals. Let me double check. It is, yeah, it's ionic. It's ionic because it's ions, but it doesn't fall under the definition of metal plus non-metal.
Because polyatomic.
Because the cation is polyatomic, it's not a metal. Yeah, so that's one of those weird ones that I'm like, okay, well, technically it's covalent if you just count the fact that it's all metal, non-metals, but that NH4 makes ion plus ion, charge plus charge, it is ionic. So you were absolutely right, but I don't want you to get tricked by like someone throwing you and saying, is it covalent? CuSO4. Yes. N2O5. Okay, H2O. CH4. N2O4. FeCl3. Okay, titanium oxide. Octane. Sulfur hexafluoride. Chromium nitrate. Ethane. Aluminum hydroxide. Carbon dioxide. Hexane. Hydrogen. Potassium permanganate. Yeah, so if you got really comfortable just doing that, that's awesome. Just double check. I was like, the only one that's tricky to me is the NH4Cl, but ion plus ion will be ionic. That one's the tricky one. So for the name, this is just going to be oxygen. Don't say it's oxide because it's not connected to something else. It's just oxygen. It's one of those Brinkelhoffs where if I was to say oxygen, you have to assume it's O2, which means down here where they have hydrogen, it's a Brinkelhoff. It's H2, not H by itself. KBr, that's potassium bromide. And if the element or the metal does not, it's a fixed number, I'm not including that. So potassium, this one is one of those that you're not going to say this is nitrogen trihydride. This is actually just going to be ammonia. That one is a little tricky just because that's a special name. Same thing as H2O. We don't say this is dihydrogen monoxide. We say this is water. So a little bit tricky because of the special naming, but those are the only two unique ones. So ammonium is NH4 plus. And I get tricked by this. I'm always flipping. And when you hear me teach it like a quant lecture, I'm like, oh, I can't remember the difference. But ammonia is NH3. Ammonium is the ion, so NH4 plus. So this one right here is ammonium chloride. Do I have any ammoniums here? Yeah, that's aluminum. Okay. C3H8, so 3 carbons. Propane. This one is potassium what? Yes. This is the one I think was wrong. What do you think it is? I think so too. The answer had hydrogen sulfide, but I think according to the covalent rules, it would be dihydrogen. I think that one had a mistake. But I'll look into it just to double check. But that one I believe is dihydrogen monosulfide. C4H10. Butane. That Cu is copper. Do I need to put a Roman numeral? 2? Okay, that was my next question is what Roman numeral? So SO4 has a -2 charge. So for copper, it has to have a +2 for it to be add up and be 0. So that's a copper 2 plus, and then this is sulfate. All right, let's do N2O5. dinitrogen pentoxide, because this is a covalent compound. H2O will just be water, CH4. Methane. All right, N2O4. FeCl3.
Iron free.
Yes. Yay. Let's go backwards here. We have titanium, and that's a 4. So that'd be Ti4 plus and then O2 minus. So what does the compound have to be? TiO2. Octane? I know. Yeah. So CnH2n plus 2. All right. Sulfur hexafluoride.
Yeah, that's
Yeah.
what it is there.
Huh?
I wrote that down.
Oh, yeah, it'd just be F. Chromium, all right, that's chromium 6 plus, and that's NO3. What's the charge of nitrate? Okay, so I'll have to definitely crisscross that one. So CrNO3 6. Did you get that? Because of the charges. You have a 6 plus here and a -1 here. So to create the compound, it needs to add up to B0. Okay. Ethane. Yeah, C2H6. Okay. Aluminum, that one will always have a 3 plus charge, hydroxide OH minus charge. So we also need to crisscross this one. So AlOH. Carbon dioxide. Hexane. All right, and lastly, potassium permanganate. Yep, and then MnO4 has that -1 charge always. Let me just double check. Yeah, -1 charge, so there's only 1 potassium. And we don't need to put any Roman numerals because we know potassium is always the 1. This is a great way of just testing your knowledge. I love the fact that it has everything included. So I definitely would come back to this before the exam and challenge yourself again. And remember that on the back we have and. The only one I disagreed with was H2S. So I'll look into that one. All right, we have some time. If you would prefer to do homework while I do this, you are welcome to ignore me. But I went into a book and I wanted to just pull in some extra practice problems. Just because when you're studying, the more you practice until you really hone that in, the better. So yeah, I kind of went through and like highlighted everything that could be useful. But since I want us to challenge ourselves, I'm gonna go towards the back. We'll do ionic bonds and compounds, since that's what we've been working on. So number 73, predict the empirical formulas for compounds formed from these ions. Lithium, so let's do 73. Let's do A, we have lithium. What's the charge of lithium? Do y'all know? +1. And then it says chloride, so Cl minus. So predict the empirical formulas. That'll just be LiCl. And the name? Yep. Actually, I like this one. Let's do 74D. Yeah, let's do 74D. So we have lithium again, but what is nitrite? NO2 minus. Okay, so LiNO2, and that would be lithium. Because you leave the polyatomic ion as is, so nitrite. What about, okay, let's do 77A. Chromium 3 acetate. So chromium will have a 3+ charge. Acetate, now I prefer to write it out like this. C2H3O2. If you have old school books, they'll do it the other way. But new textbooks will show C2H3O2. What is the charge? So I will need to crisscross. And even though it is a bigger polyatomic ion, we still be consistent. So Cr, and then in parentheses, I'll do C2H3O2, and there are 3 of them. So that's our overall answer. So chromium 3 acetate. So it's pretty straightforward. I think the hardest part now is remembering what polyatomics are. Let me see if I have another one. Or I can, how about I just zoom and I'll let y'all do. I like 79. Let me see. Go ahead and do the rest, or 79. We just take, okay, do 79, A through D. And I'll do it on my own on the side and we'll check answers. But just like here, the way that I would write my notes is you always want to start off with the metal charge and then double check before you do the full answer. And then you can write, once you have this correct, you can write the answer. I realize now that they gave you the name. You don't have to name it, you just have to write the formula. No, because it's by itself, like there's a 1, you can just, no parentheses. Only time you put a parentheses is if there's more than 1. So for 79A, I got CrClO3. So 79A, I got ClO. So CrClO3. Did y'all get that? For B, we did that one kind of earlier. So KMNO4. And then C, I got NaCN, since that CN is a -1, Na is a +1. And then for the lead chromate, I got PbCl3. ClO4 2. Did y'all get that? Awesome. I really like 81 because it really challenges you to figure out what is the charge of each of those metals. So y'all go ahead and do 80, actually, I'll do 81A and then we'll do 81 by, and by the way, if you're have downtime and you want to move to the problem next door, it's the same exact problem, but with more practice over here. So if you're waiting and you want to get a head start to something else, you can do this stuff too. So 81A, we have SnCl2. Remember that the way that you figure out what the charges are is you look at the elements that are definitely have a specific charge. Fluorine will always have a -1 charge, and there's 2 of them. So for this, you know, if I add number plus this to equal 0, what does that number have to be? +2. So the charge of the 10 is a +2, and those chlorines are a -1. So it's just asking to figure out what is the charge on the metal. So 81, do B through D, and if you want to keep going, do these.
So it's just asking for
The charge of the metal. Yeah.
they don't have to rewrite it.
No, just the charge of the metal. So I'll do my own on the side. And I think I'm going to do the other side too, because those look pretty challenging. I think this one's really good. This 82D. This one's a good challenge. Any more time? Okay. So what did you get for 81B? Yeah, me too. I got +4 because each of those chlorines are a -1, so 10 has to be a +4. What did you get first? Yes. So each of those nitrates are a -1, so the lead has, or sorry, yeah, that's lead. Lead has to be a +2. What about the iron for D? +2. Carbonate has a 2-. And so for this to equal out, the iron has to be a +2. All right, so what about this silver? The good news here is that silver is a fixed one. It will always be +1. So I don't know why they threw that one in here, but silver here is always going to be +1. There really wasn't no need for math, but phosphate is a 3 minus, and so that's why this one is always going to be +1. What about B? +2. Acetate has a -1 charge. There's 2 of them, so this has to be a +2. What about indium? +3. Bromine's always -1. There are 3 of them, so that means indium has to be a +3. Here's the fun challenging one. What do you think? Yes. So there are sulfates, there's 3 sulfates at a -2 charge. So overall, sulfate is contributing a -6. So over here, we have to have a +6, but there's 2 of them. So each of these chromiums are contributing a +3. So that's a fun one here, but that's exactly what you need to do if you don't have, or they don't give it to you. You can kind of go backwards, and it's a great challenge. Why don't we practice naming 85? So I'll let you go ahead and do 85 A through D, and then if you want to get a head start, you can do the rest for 86. Got any more time? Okay, take your time. Ready? Let's do 85A.
Iron 2 carbonate.
Yes, carbonate will have a 2 minus charge. the iron has to be a 2, and you have to incorporate the Roman numeral. So iron to carbonate. What about B?
Green nitrate.
So this would be aluminum nitrate because aluminum is one of those fixed rates. So you can see like that, there's a few fixed ones. That's aluminum in the transition metals. So aluminum, zinc, cadmium, silver. Those are the 4 ones that will never need a Roman numeral. Aluminum, zinc, cadmium, silver. So aluminum's 3+, zinc and cadmium are 2+, and silver is 1+. So this would be aluminum nitrate. What about C?
Barium.
Barium nitrate. Barium's fixed, column 2. What about D? Ammonium sulfate. So the hard part, of course, is remembering the names. But once you're past that, it's really nice that I don't have to worry about all these freaking numbers. I can just say the polyatomic as is. I don't care that there's 2 of them. It's just ammonium and sulfate. Ammonium sulfate. All right, what about this one? Double check. I think that's a chromate, right? Is that chromate? Dichromate, right? No? Dichromate. Okay, yeah. Sorry, I'm looking here. You see, even I struggle. I'm like, is it a chromate? Nope, it is a dichromate. So that would be sodium dichromate. B, what about this one?
Silver hydroxide.
Yes, and we don't include the Roman numeral, so silver hydroxide. All right. C,
Carbon.
yeah, zinc carbonate or zinc. Oh yeah. Zinc is a fixed one. It's always a 2+. So zinc carbonate. And then this one. Okay, so we kind of did the same one up here, right? We know there's 2 of them, but there are +3 charge. This would be chromium 3 sulfate. Because each of these chromiums are a +3. So chromium 3 sulfate. Class time's pretty much over, but yep, class time's over. My advice, at least before next class, is to finish 2.1 homework. And then I feel like y'all have gotten so much more comfortable with this over this class. In the beginning, like just because it was new, but I think don't ignore this until the exam. So maybe take a peek at it. We have a quiz. Maybe when that quiz comes out, try to do it in this week. Don't wait towards the end. So that way it stays fresh in your mind because y'all seem very comfortable. And then these are extra practice if you want. All right. I will see y'all on Friday. Have a great rest of your day. You're welcome.